This is the video for section 4.2 notes, slides 11 and 12. All right, so we're talking about the mean value theorem. Determine if f satisfies the conditions of the mean value theorem. If so, find all possible values of c. All right, so remember, the conditions of the mean value theorem are continuous on the closed interval, so from -4 to 1, and differentiable upon the open interval, so from -4 to 1. All right, so first of all, is this function continuous on the closed interval -4 to 1? All right, so we take this. Remember, this really means 3 times the square root of x plus 2, right? And so we know that this graph is the square root graph that has been vertically stretched by 3 and shifted up by 2. And so we get this graph. So is this function continuous on the closed interval -4 to 1? Well, the answer is no, right? Because it's not continuous from -4 to 0. It doesn't even exist from -4 to 0, right? And so we would say f is not continuous, continuous on -4 to 1, right? So the mean value theorem does not apply. All right. Now, we also, let's say that it was, right? Let's say that it did apply, right? So then the next thing we would do is we would want to find f prime of x. All right. So we want to do that. So 3 times the derivative of x to the 1/2. So that'd be 1/2 x to the -1/2, right? And then plus 0, right? So really, this is just 3 over 2 root x, right? So that is the derivative. So now you'd have to say, okay, well, is the derivative defined on -4 to 1, not including the endpoints of -4 and 1, because remember, a function is not differentiable at its endpoints, right? So now you would say, okay, well, when is this thing undefined? Well, you would say that f prime is undefined when what is true? Well, when x is less than or equal to 0, right? So it's not differentiable at any of those values, okay? And so you would say, once again, of course, so f is not differentiable on -4 to 1. And then, of course, so the mean value theorem does not apply. Now, you don't need to say both of these things, right? If one of them is true, right? Like if f is not continuous, right, then you're done, right? Uh, but if it is, then you need to go on and say that it's not differentiable, right? Now, first thing you check is continuity, then you check differentiability. If both of them are satisfied, then you go on and you continue with the mean value theorem. All right, so now let's think about the next one. All right. So, first of all, is this function defined on -2 to 1, right? Well, yes, it's a quadratic, right? You know that any quadratic, right, is just a parabola, right, like this. So it is defined on all real numbers, right? And of course, then it would be defined from -2 to 1, right? All right. So then you want to find f prime of x. All right. And so derivative of 3x squared is 6x plus 2, right? And so now the question is this thing differentiable upon the open interval -2 to 1? Well, of course, 6x plus 2, right? That's just a line slope of 6, y-intercept of 2. So, of course, that thing is going to be defined everywhere between -2 and 1, right? And so what you want to say is you want to say f is continuous on -2 to 1 and differentiable on the open interval -2 to 1. Remember, it's got to be an open interval just because a function is not its derivative is not defined at endpoints, right? And so if we're restricting the domain of this function from -2 to 1, right, then it won't be differentiable at -2 and +1. All right, so f is continuous on the closed interval -2 to 1 and differentiable upon the open interval -2 to 1. So the mean value theorem applies. All right, so that means what? Remember, mean value theorem says f prime of c equals f of b minus f of a over b minus a, right? And so in this case, right, we have f of x, 3x squared plus 2x minus 7, right? So f prime of c, so that'd be 6c plus 2, right? So f prime of c equals f of b, right? So that's going to be 3 times negative 2, sorry, b I use as 1. So 3 times 1 squared plus 2 times 1 minus 7. Right, all of that minus f of a. So that'd be 3 times negative 2 squared plus 2 times negative 2 minus 7, right? All over 1 minus negative 2, right? So now 6c plus 2, now we just have a little bit of work to do here, right? So 3 plus 2 minus 7. So 5 minus 7 is negative 2 minus, all right, so 3 times negative 2 squared, 3 times 4 is 12, minus 4, right? So 8 minus 7. 8 minus 7 is 1. So negative 2 minus 1 is negative 3 over 1 minus negative 2 is positive 3. So that's positive 3. So we get negative 1. So 6c plus 2 equals negative 1. And so c equals, if I subtract 2, I get negative 3 over 6. So c is equal to 1/2, right? So remember, c is the x value for which the derivative, right, has the same value as the slope of the secant, right? So remember, the mean value theorem says that the slope of the tangent is equal to the slope of the secant at least one value of c that's on the open interval. Remember, it has to be between, right, negative 2 and 1. So when we get c equals 1/2, we better make sure that it's in between negative 2 and 1. Now, what if the value that we get is not between negative 2 and 1? Well, then we made a mistake, right? Because the mean value theorem guarantees that this is true. So, what must be the case? Well, either you incorrectly determined that it was continuous and differentiable, or you made some numeric mistake, or you made a derivative mistake, or you made some algebraic mistake. But you definitely want to go ahead and check that out. All right, so that